What is up? Daniel here with the Virtual Robotics Studio, and it's time now for our teleoperated code, or driver control mode. So you're going to need to get out some sort of gamepads. I think we got some Logitech ones in the kit of parts. That's what we're going to use, but Xbox controllers, PlayStation controllers, they're all going to work. So get those ready, then we're going to start coding. But before we do, a special thanks to Argosy, First, Aramco, and Team 302, Lake Orion High School, for hosting our studio. All right, first step, let's go ahead and reopen everything on the computer. So if you were working on code and you stopped and now you need to open it again, if you go into WPI Live VS Code on the same computer, in theory, it's going to open up to right where we left off. So that code is just going to be right there, ready to go. But if it's not, so let me go ahead and close everything out here. If you open it up and you're back on this screen, the way to open this, it's not open file. It's going to be open folder. So choose open folder. And then I think we put it on the desktop, and then we're in 2026 FRC code. And the version we're working on is 2026 Kitbot, or I'm working on is 2026 Kitbot. So either select the folder here and choose select folder, or you can actually go into that folder and then choose select folder. And that will then open up all of the code that we did before, and we're back. So keep that in mind. Next step, let's see. Yeah, let's go ahead and also run our driver station software here. We'll get that going. OK. And we don't have robot code yet because I didn't turn my robot on. Let's get a little bit of code going, and then we'll go ahead and turn the robot on when we're sort of ready to test our first thing, which will be pretty quick, I think. OK. So the first thing we have to do, at the very top of our code, we're going to need a new import. I'm going to put it, I guess, down here. By the way, it is still, in theory, opening my project. We can start working while it's doing that, but just keep that in mind. So we're going to do an import. I see. And if you are stuck with this opening stuff happening, that is why I'm not getting autocompletes, I believe. All right, but we're going to import. It's going to be edu.wpi.first.wpilibj. And then it's going to be Xbox controller. And it will be capital X and capital C on Xbox controller. Let's see how we're going here. Initialize workspace 20%. Feels kind of slow, but all right. So we have this first line. We'll check on that once it's done loading. But now we actually have to plug our controllers in. So these, I think, are the ones that come in the kit of parts. They work fine. They're like Logitech F310s. I think if you have genuine Xbox controllers, they might be a little bit better in terms of the linearity of the gamepads, of the joysticks. It's not that big a deal. My team has definitely used these for entire seasons before. But if you have a nicer controller, go ahead and use the nicer controller. That said, I think your best bet is either these or any controller that basically mimics a Xbox controller or an Xbox controller. Because if you're using a different controller, you will need to change some of this code. But let's get these plugged into the computer. And I have two of them. They look the same, except I put red tape on one. So this one, typically the way teams do it is they'll have one driver that drives the robot around and one operator that does things like turn the robot into loading mode, launch the balls, etc. and whatever. I guess on this robot that's about it. But usually that gets split up just to make sure that the cognitive load on any individual driver is not too big. But that said, sometimes if it's just like drive and press the button to launch, that could all be your driver doing it. I think it is nice to have somebody else who turns on and off the loading mode when you want to load. All right, so I'm going to plug these into my computer. Whatever USB ports you have. And then if we go to our driver station here, in the driver station, if you go to the USB tab on the side, it's going to be the fourth one down. you'll see now that it is populated. It's green for 2 controllers. Like if I unplug one of the controllers, it's going to turn gray like that. When they're green, you can actually tell which controller is which by pressing the buttons on the controller. So if I press the buttons on the controller, you can see which one is flashing. This one is 0 is flashing right now. And I can also move the joysticks around. You can see the joysticks that are being moved and what values they're reading in and what buttons are being pressed. So I know that right now, controller 0 is the one without my red tape, and controller 1 is the one with the red tape. Let's see if that one is. Well, that's kind of interesting. Try unplugging that one and plugging that one back in. There we go. That's interesting. The, oh, there we go. Oh, no, that's weird. OK, so it looks like the button read-in is just for the selected controller. So I was on 0, now I'm on 1, now it moves. But I was just seeing, yeah, you see the light up that's happening? OK, so my problem is this. The red tape, I believe last year was my driver controller. So I want that to be import 0. But when I push the buttons on that, that is the one import 1. So if you have that happen, here's how you change it. All you do is drag the controllers to the positions you want. So I can drag controller 1. I can make it be, whatever controller 4 instead. I can put it as controller 0. So now when I press the ones on the red tape joystick or gamepad, that is showing as controller 0. And the other one is controller 1. So that is looking perfect. OK, and let's see if my environment finished loading. It did, yeah. So now instead of these all being white, they are the greenish color. If you have to, if it's just sitting on there forever, I have had it in the past where you just got to close the window and open it back up again. So that is an option. I guess like start over is always an option for electronics. Turn it off and turn it on again. All right, so we have our Xbox controller. We can actually go back just to make sure. It did change colors, right? But doing the dot and making sure that at the end at least you can autocomplete is good to make sure that everything is spelled right. But we now have the ability to use Xbox controllers. Now we have to set up our driver controller and our operator controller. So we're looking at the section that's public class robot extends timed robot. And we have all of these private final things. We can really put this anywhere. I want to put it above the fuel mechanism parameters. I don't know. For me, I like having that be the last thing down here. Or our variables to be there, because all of our devices are kind of up here, and I want it to be part of that section. So we're going to do a private final. And this is going to be an Xbox controller. And again, the line doesn't matter. I mean, like in theory, you could even do this in between, right? Like left drive lead and left drive follow, and it would work. The order of these lines in this section, as long as they're all in this section, is really just for us to keep things organized. All right, that is going to be the next thing we have to put is the name of it. So we're going to have our driver controller, say, equals a new Xbox controller. And then it's asking for the port. And like I said, we already set the port, right? Remember the drive 1, I spent the time dragging it up, so that one was import 0. And then we need to do our second one, which is a private final Xbox controller. And this is going to be our operator controller. I guess op controller seems good. Equals new Xbox controller. And this one is import 1. And just a reminder, the gray writing here, that port colon, that is a label. I did not type that. You just have to put the number inside there. It will add the label for you unless that setting is turned off. All right, so now we have our 2 controllers that we can access and use. I think now we're ready to jump down to Teleop. Oh, you got to get through all of our autonomous stuff. All right, here we go. Teleop init. And in Teleop init, we really don't have to do anything yet. There is this world where the timer we were using in autonomous mode, we could turn it off. So we could do auto timer dot stop. That was start dot stop. That is a thing you could put here. So it's like we're done using that timer. No sense in wasting any, whatever CPU usage or memory keeping track of it anymore. It probably doesn't matter. This robot is simple enough that we're not really taxing the RoboRio in any way. So, it's a good thing to do, but you don't have to. All right, now let's get into Teleop periodic. This is where we really are going to start doing our code. And let's start with just like, hey, let's get the drive control kind of generally working. And then maybe we'll add some additional stuff to that. And then we'll get our intake and fuel mechanism working. And then we'll maybe add some more features to that as well. All right, so first thing is let's do our drive. And the drive is pretty easy. It is just going to be the name of our drive, which was my drive. And we created that differential drive in the auto mode program. And we're going to do dot. And we can do tank drive. We're going to test both. So we're going to do dot tank drive. And remember, it's asking what power should go to the left motor, what power should go to the right motor. I think in this case, right, if we look at our controllers, we've got the two joysticks on them. And that's kind of like what we would be using. So we have these two joysticks. I think in tank drive mode, what makes the most sense is if I take the right joystick forward and backwards and make that control the right wheels, and the left joystick forward and backwards and make that control the left wheels, then we can drive forward by pushing both of them forward. We can go backwards by pulling them both backwards. And we can turn, again, it's differential drive, by going forwards on one and backwards on the other. And of course, you can go any percent in between. You don't have to go all the way. So that's generally how I would set up a tank drive. So let's do that. To read in the value from a controller, we have to start with the name of the controller, which is driver controller dot. And then after you do the dot, you get the list of basically everything we can read in from the controller. In this case, we're going to do get. Let's do left first, because that's what it's asking for. This is the left speed. Get left. And then we have get left X and get left Y. Y is up and down on the controller, and X is side to side. So we want get left Y. Then for the other one, it's going to be very similar, except it's going to be driver controller dot get not left, but right Y. Now we have one more problem. I could let you download this code. In fact, if you want to experience the problem, go ahead and download this code and see what happens. I'm pretty sure that these joysticks are backwards. So you would think when you push it forward, you get positive numbers. But actually, when you push it forward, you get negative numbers. So pushing forward on both joysticks would technically make the robot go backwards, which is not what we want. So we can fix that in code. We talked about like reversing motors before. That's not what we want to do here, because we want a positive number to be forward. We could reverse the controller, but that's not a built-in function, I don't believe. So instead, what we need to do is just throw a negative sign in front. So minus the value of that. That's the same thing as basically saying -1 times the drive controller. So take whatever that value is and flip the sign. But you don't need to do the times. Just putting a minus there says, hey, put a minus sign on it. Do that for both of them. And actually, at this point, let's turn the robot on, because we're ready to deploy the code. That's all we needed to do. So flip the switch on here. We got the lights lighting up. And remember, if you're turning your robot on, if you just changed the battery, if this is a brand new meeting, make sure your programming laptop is connected to the robot. If it's not connected to the robot, we cannot download code. So I'm going to open my wireless networks, and it ain't there yet, but soon. Remember, it takes about a minute, 45 seconds to a minute for the radio to fully boot and be available to connect to. And it seems as though I have not quite talked for long enough for that to be the case. Let's search again. It's got to be close now. Like, we got to be there, right? 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 There it is. All right, so connect to your robot. And just because when you deploy, right, like it takes a little bit of time. So instead of getting an error, you can also look on your driver station. And if you see all of the green lights, that is your green light to go ahead and click the WPI Live icon and deploy the code. Yeah, and you can click on it. You can tab to autocomplete. An out of memory error, huh? All right. Is that easy? You can just click a button that says increase memory and it fixes it? I don't think that's actually a problem. I think we can just keep going. All right. Let's close that. Now this time, when we go to start, it doesn't really matter what's selected from our smart dashboard because we are not running in autonomous mode. Click teleoperated mode. That's what we're going to be testing now. And again, we're going to enable, but be ready to disable right away. Like sometimes gamepads can send erroneous values to the robot, and the robot might take off and start driving right away. So anytime you're enabling it with new code, always be ready to disable it. Actually, just generally, you should always be ready to disable. All right, let's go ahead and try the enable button here. And that is enabled, and nothing is happening. That's what we wanted to see. Now, if I pick up the red tape controller, that's the drive controller, what we should have is if I push forward on the left joystick, the left wheels should move forward. So that's what I'm going to try. So if we go slowly on that, OK, that was not slow. Let's go backwards on the left joystick. So you can see, in fact, the left side is moving forward and backwards. It's a little touchy. This thing goes. All right, let's center that back up. Let's try the same thing, but with the right controller now. So now I'm going to do the right side. And right side forward and backwards is looking good. Cool. And so now let's see. If we go forward on both, whoa, backwards on both, forwards on both. We can try to turn by going forwards on one and backwards on the other. And yeah, that is working. Everything is right. Obviously, there's a few things that we might want to think about, which is like just turning to face. Like if I'm here and I want to turn 180 degrees to face the table that's behind it, like it spins so fast that like we got it, but it wasn't, you know what I mean? Like it's not easy. I'm kind of just tapping the controls, and that's almost the slowest that I can get it to, or the least I can get it to turn. If I go really slowly on the joysticks, maybe you can do a little bit better. But we're running into an issue here where at full speed, this robot, it just jumps around. It's very quick. It turns very fast and accelerates very fast. So we may look at how we could scale down the speed at times. So we have a slower, more controlled mode and a fast mode when we want to cross large distances. The other thing that we want to look at is, remember, I've driven robots a lot. If I want this robot to go straight forward, I want to just creep forward. I don't want to turn at all. Let's say, for example, let's say there's a ball right here. I need to go straight forward, but if I start turning, there's a good chance I'm going to just hit that ball and push it away. In tank drive mode, this is kind of the one big negative of tank drive mode, is if I want to kind of do this fast, it's really hard, because if I don't push both joysticks evenly forward together, the robot's going to turn some, and I'm not going to get that ball. So we can go ahead and try it. That time, I was able to just keep it even. But you can see, like, if you're just a little bit off when you go forward, that robot can just turn a little bit, and that little bit of turn when you start going is a problem. And if you start trying to creep forward, it's almost harder to creep forward evenly. Like, there's a little bit of a turn, and then I can correct it, but that one quick movement, like you saw when I backed up there, it curved right away. So that one quick movement of straight forward and straight back is a little bit hard in tank mode. Now, if your driver loves this, maybe your driver drives like a skid steer, forklift, I don't know, at home, and they're really used to it, by all means, use this control scheme. There's no like right or wrong answer. But let me go ahead and disable, by the way, and then let's go into our code. Instead of mydrive.tankdrive, I'm going to show you what arcade drive does. So let's comment out the mydrive.tankdrive line. Remember, 2 forward slashes, turn it green. Let's add a new line, which is going to be mydrive.arcade_drive. Now, the way arcade drive works is instead of giving it a left motor power and a right motor power, what we're actually going to do is we're going to give it a forward and backwards power, a movement power, and then we're going to give it a turning power. So the way that we'll typically do that is we'll split the joystick up into 2 parts so that the left joystick forward and backwards is going to make the entire robot move forward and backwards. And it will go straight forward and straight backwards-ish, mostly. And then the right joystick left and right, x-axis on that will control the turning. This means that if I need to creep forward a little bit, I can just creep forward by pushing the one joystick forward, and I don't have to worry about being balanced with how much I'm pushing them both. So that's, I think, a little bit easier to control to go straight, especially if you're just starting. Now, this method of control also is going to be a little bit more familiar for anybody that plays like video games on console, on like PlayStation or whatever. If you play a first or third person game, usually the left one will move you forward and backwards, sometimes side to side as well, and then the right joystick will be how you look or how you rotate. So a lot of times people that play a lot of video games are going to prefer this arcade drive style more. So let's finish this out. So arcade style, our forward and backwards, we said that was going to be driver controller dot get left Y. So we're actually not changing anything on this one. And by the way, it is still negative, so go ahead and throw your negative driver controller dot get left Y in there. And then the other one, we're going to do driver controller dot get right, and this time it will be X, because we want this to be steering, we want this to be left and right. And I think, I'm not 100% sure, but I think this is backwards too. So let's do a negative on both of them again. All right, let's deploy this code. It's going, it's going. That one felt slower than the previous one. I don't know why. All right, close the log, and let's enable. All right, and now we're enabled. So on the controller, if I just do this one forward and backwards, the whole robot should move forward and backwards. So let's see if it does that. Yep, forward and backwards. And you can see too, like I can do this so easily. I just want to creep straight forward. I can do it with any finger. I could probably do it with my face, because of course if I only touch the one joystick, it's going to go forward and backwards. So that helps a lot for that slow, like, oh, ball's right in front of you. And then now let's try the right joystick. So left and right on that should give us rotation. And that's good. And then it is still possible, right? Let me back up, get myself some space. It is still possible to go forward and turn at the same time. So you can still balance those things out. All right, so that is arcade drive. Pick your favorite. In the code here, let me disable, but in the code, pick the one you want. If you prefer arcade drive, leave arcade drive uncommented out. If you prefer tank drive, then uncomment tank drive and comment out arcade drive. I'm going to leave mine at arcade. I'm a convert. I used to like tank drive more, but I'm converted to arcade drive these days. All right. Let's get full functionality. I think there's a really good chance we're going to want to come back to our drivetrain. And like I said, when you're, like, say you go full speed, you rip across the field, you're by the hub, and now you want to aim perfectly at the hub, I think there's a good chance that we're going to want to have a slow mode where you rotate slower or you drive slower, where you can get that fine-tuned positioning so you're the right distance from the hub, you're pointing right at it, and you have that control. So I think we might want a slower mode that we use to control stuff, and then be able to switch between the slow mode and the fast mode on our drivetrain. But like I said, let's get full functionality. Let's get our fuel mechanism working, intake, eject, and launch, all the same things we talked about in auto mode. And then we'll come back and we'll add some more stuff to our drive. All right, so next step is, it's a few things. The first thing is, well, I mean, we can get started. Let's do an if. And open those parentheses. And inside the parentheses, we're basically going to start reading if buttons are pressed. So one of the things is, so on our op controller, dot, and we can do get, and choose whatever button you want. So on here, right, there's A, B, X, Y, left bumper, left trigger, right trigger. We got, you know, whatever, but you can even use the directional hat if you want. They're all in here. Pick the ones you want. Remember, we're going to have 3 buttons here that are going to be controlling stuff. One button is going to be to turn the intake on so we can drive around and floor load balls. One button is going to be to eject the balls out. So if things get jammed, or you can actually feed them to the human player, or there are some strategies maybe where you drive around and collect balls and then you spit them out to your partner, who then picks them up and launches them in the goal. You might do that by launching them, though, and not ejecting them. So we have the eject button, which will run everything backwards to spit the balls out of the hopper. And then we have the launch button. The launch button's a little fancy because we have to do our spool up time and then launch, but it's going to be 3 buttons that you're using. And if you want to use A, B, and X, that's great. If you want to use like A and B for intake and eject and right bumper for launch, that's great. I'm going to use the same buttons that is in the first default code. I don't know if I like them the best. First default code I think has left bumper is intake, right bumper is launch, and the A button is to floor load, or is to eject, sorry. So left to floor load, right to launch, and A to eject. I don't know. If that makes sense to you, that's great. I'm not really sure what I would think. Like maybe like Y is launch and A is floor load, and I don't know. Or maybe right bumper is launch and A is to load in and Y is to load out, or the opposite. Whatever makes sense in your head, that's what you should use. But again, like I said, I'm going to stick with the buttons that they chose to use. So I'm going to do the first thing that we want is get, this is going to be right bumper button. There are 3 choices here. We have right bumper button, we have right bumper button pressed, and right bumper button released. Here's the difference. Get right bumper button just gets the state of the button. Is it pressed or is it not pressed? True or false? Right bumper button press says, is it pressed for the first time? So when you first press the button down, like when I press the right bumper button down, right bumper button pressed will be true one time when it was initially pressed, and then it goes back to false. So that's basically saying, like, did you just press it? Was it pressed? Was this the initial pressing time of the button? And released is the same thing. That will run once when you let go of the button. So in our case, in this situation, if you're holding the button down, we should go into launching mode. We should stay in launching mode. So we're going to do get right bumper button. Now, I told you this is reading in as just true or false. If the button's pressed, it's true. If the button's not pressed, it's false. Remember, if what we put inside the parentheses for an if that's true, if the statement we put in there is true, it runs the code. If it's false, we don't run the code. Well, this is true or false. So if it's true, it's going to run the code. And if it's false, it's not going to run the code. But if it helps you to visualize what's going on here, it's the same thing as saying, is the bumper button equal to true or pressed? Then it will run our code. But because it's already true or false, we don't need that. We can simplify our code a little bit. Now do your open and close curly braces and put those in here. And I'm going to, again, kind of lay out the framework, and then we'll fill it in. So we'll do the // to get a comment here. And this is launching mode. All right. Then if you go below the curly brace for that, we're going to do else if. And now here's the other thing. The reason why I put them in this order, too, is that the order that we put things in this if-else if is going to determine the hierarchy. So for example, if I push the right bumper button and the left bumper button at the same time, what should run? Whichever one is higher up runs over the other ones. So in this case, if you're in launching mode, I think that you should stay in launching mode even if you accidentally bump other buttons, because it's got that spin up time. We don't want to have to re-spin up and things like that. So in this case, because we put it first, the launching button trumps everything else. If you push 2 buttons at the same time, we're going to launch. Next, I think the next most important button is the floor load button. So let's do else if op controller dot get, and that was, like I said, the left bumper button is what they had chosen for that. Okay, then that is floor loading mode or intaking mode. Quote, intaking. All right. And then go below the curly brace for that else if, and we have another else if. Okay, and this is eject mode. And so here we're checking if op controller dot get a button, not a button, the a button is pressed. Then, and I'm going to add my curly brace, and this is ejecting balls. And then we finally need, if you're not pressing any of the buttons, we need to turn stuff off. So we have one more case at the end, which is else, which is turn stuff off. Okay, and again, like there is a hierarchy here, right? So if you press the left bumper button and the A button at the same time, we are going to run floor loading mode. If you press just the A button, we're going to do ejecting mode. If you do all 3 buttons, it's going to run launching mode. Probably doesn't matter. You shouldn't be pressing multiple buttons at the same time most of the time anyway, but we're just trying to make it as safe as possible. Okay, now let's start with turn stuff off mode because that's the easiest. Remember, we have two motors that we're controlling. We have our the one that is both the intake roller and the launcher wheel. And then the second one is that feeder roller. So if we do, what was it called? Intake and launcher roller dot. And we're going to do set voltage to 0, because 0 means off. All right, and we have to do the same thing for the feeder roller. So feeder roller dot set voltage 0. Okay, so if we're not pressing any buttons, no power goes to either motor. Great. Now, here's where some of the work we did before is going to help us out. Let me scroll up briefly. Do you remember, I mean, I did mention them today, all of our fuel mechanism parameters? Look, when we're intaking, it's just these values. When we're launching, it's just these values. When we're spinning up, it's just it's this value and technically this value for this long. And when we're ejecting, remember I said it's just negative these values. So let's go back down. Let's do intaking mode next, because that's the second easiest one to do. So get left bumper button, floor mode, intaking mode. Go inside those curly braces. And all we have to do is, again, we're going to do intake and launch roller dot set voltage. But in this case, what we can do is we can use that variable, which was intaking intake voltage. So remember the intake and launcher roller gets the intake voltage. And then we have our feeder roller dot set voltage. And that has our intaking feeder voltage. So now we're in intaking mode, so that is the voltage for our intake slash launcher, and that is the voltage for our feeder, which is whatever we put on that table, which if we have to tune later, we can tune later. Okay. Then for ejecting mode, it's going to be the same two things and almost the same code. We just have to change the direction. So intake and launcher roller dot set voltage. And all we're going to do is do a negative sign first and then do intaking intake voltage. So now whatever direction it was running to intake the balls, to suck the balls in, we're going to spin it to spit them back out. All right, and then feeder roller dot set voltage, and that is going to be negative, and this is going to be intaking feeder voltage. All right, I think we want to test this because launching mode is a little bit more involved because we have to have that spool up, that spin up time before we actually launch. So let's deploy this and make sure our other cases are working. Deploy the code. Yeah, while this is deploying, I will mention there is one more thing to think about, right? Which is if you are in this mode and then you hold this button down, we don't technically do anything with the voltages, so it would continue doing things. So basically, we're going to not press the right bumper button, and we won't have any bugs with this test. OK, we are up. Let's go ahead and enable IntelliOp. All right, and we're just going to kind of, well, first, we can still drive, so that's good. I'm gonna bring the robot a little closer to me. Man, that turning is still wild. All right, so robot's a little closer. We can kind of see what's going on. When I press the left trigger button, it should be in intaking mode, and we should be able to floor load a ball here. So let me untangle my cords. All right, let's try it. So kind of just tapping it, I can see the way the rollers are going, and it does look like they're going the right direction. But the easiest way to kind of know if it's working or not is let's get a ball. I would say that is intaking mode. Let's test it again. Cool. All right. And then the other one we can test is the A button should put us in ejecting the balls mode, spitting them back out. So let's press the A button. And I would say that works. OK. And when I let go of the buttons, of course, crucially, it doesn't do anything. All right, click disable. We're close. We got two of our functions are working. We do need to get our launching mode to work. Now, here's the thing with launching mode. You remember launching mode in auto mode? We got to do 1 second of spin up. Then we can start feeding the balls through. So somehow we have to keep track of that time. So let's go up, let's add another timer. Remember I said we're gonna do probably 2 timers. We could reuse the auto timer because we're not using it during teleop. It would be fine to use the same timer, but I'm gonna make another one just so we have different, it's more clear that there are different timers doing different functions. So in the code, if you scroll up to, again, public class extends timed robot, we're looking for where we made our other timer. I like to keep them together. And we're just going to make a new line of code here. It's going to look the same. Private, final, timer. Nope, timer. And then the name of it, this is going to be our, this is like our spin up timer. So we'll call it the spin up timer equals new timer. Okay, then we got to go down to teleoperated init. So where we stopped the other timer, here we need to start the new timer. So that was our spin up timer dot start. And we also had the spin up timer dot reset here for the auto timer dot reset here. I don't think we need that for this one. Because the way this works, we're going to have to reset it in a different location. And that's what we need to figure out now. Let's see. Actually, while I'm here, I'm going to do a couple of more spaces. And I'm going to do a comment line here. This is fuel mechanism. Right? And then this section here is drive. So again, we just have some labels to keep our sections a little bit separate. Now, in the fuel mechanism section, we need something brand new at the very top. So basically, here's the way it's going to work. When you press the right bumper button, inside this if case, we need to say, OK, we're in loading mode for 1 second. And then if you keep holding the button down after 1 second is done, and we've, sorry, not loading mode, spin up mode. After 1 second and we're done spinning up, then keep holding the button down, it will start launching. We go to launching mode. But somehow we have to know when that button is first pressed so we can start our stopwatch at the right time. And if you were listening when we talked about buttons at the beginning, we have the ability to check if it was pressed, not if it's on, not, remember get right bumper button pressed, get right bumper button released, or get right bumper button. In this case, we can use pressed to know when it was initially pressed. But we can put this code, we probably could put this code inside here. I don't know what's better. Sure, let's go inside. I changed my mind. We're going to try this a different way because I think it makes more sense and hopefully it still works. So now the right bumper button is pressed, right? The question is going to be, though, is on op controller, the get right bumper button, is it pressed? So if the bumper button is being held down, right, it's being pressed. It might have been pressed for a while. It might have just been pressed. We'll run this code. The next one is saying, OK, bumper button pressed really says, did it just get pressed? Is this the first time through the code that I've seen the button pressed when it was not pressed last time? We call it a rising edge. It goes from 0 to 1. So like the signal would get bigger, rises up. So in this case, right, this is when it was first pressed. This is when we want to reset our stopwatch so that we have that 1 second from initial press of spin up time. So let's do our spin up timer dot, and we're going to do reset. So our spin up timer is now back to 0. So anytime you let go and press the button for the initial time, the initial press on the right bumper button will reset our stopwatch, will reset our spin up timer. And now we can use that information. So now our next question is, like in this area, should we be spinning up or should we be launching? If spin up timer dot get, and we want to know, is it less than? And really, I'm going to scroll back up here. We could just type the number 1, but we do have one of our parameters here, one of our save up things for spin up seconds, right? And that's how long we need the spin up to be. We use that in autonomous mode in a few places. So again, if we decide, oh man, our motor is just a little tired these days, it needs 1.5 seconds to spin up before we launch, or you just find that that's more accuracy in launching, then again, you can only change it in one place and have it fix everywhere. So instead of just putting the number 1 here, so get back to where we were, if spinuptimer.get is less than, it's going to be like saying a 1 here, but instead we're going to use that variable, which is our spin up seconds. Then we should be in spin up mode. So we can actually, we'll make a note here. So this is spinning up the launcher, which means our intake and launcher roller dot set voltage is going to be equivalent to our launching launcher voltage. So just like in auto mode, when we're launching or spinning up, we're turning that motor on to the correct power, and the spin up is just giving it time to get there. We don't need to change the power for the launching wheel, but we do need to have a different value for our feeder wheel, and that's what we're going to do next. So our feeder roller dot set voltage. And again, this one has another variable for it. So this is the spin up feeder voltage. So now, if the button is pressed and the button was just pressed, we reset our stopwatch. If that stopwatch is less than 1 second, or our spin up seconds value, then we go into spin up mode, which is running the feeder roller backwards to keep the balls from popping out and starting our launcher at full speed. Then, if it's not less than 1 second, we should be launching. So we don't need another else if, we just go else. If we're not in that spin up time to just launch. And intake and launcher roller dot set voltage is not going to change. This is going to continue to be our launching launcher voltage. But our feeder roller will change. So feeder roller dot set voltage is now going to be our launching feeder voltage. All right, and I guess I'll take that space out. Okay, so now we have our launching mode, in theory, in here to test. We have our loading mode, we have the ejecting mode, and we have turn off. So we're going to make sure all of that still works. Now, I'm going to give you, we did this in kind of a not the safest way. Ideally, you want to make sure that only one set voltage ever runs in your program. And one of the ways that you can do that is by only having a single set voltage in your program for every item, right? Like if there was only one line that said feeder roller dot set voltage, then we know it can't run in multiple places. But in order to do it that way, we would have had to make another variable. We would have to save these values to that intermediate variable and then pass that intermediate variable into our feeder roller and our intake and launcher. And that does make the code a little bit more complicated. So we're trying to keep it a little bit simpler, but we're safe because if, else, only one of these can run at a time. But if you make a mistake and you have an extra if here, now all of a sudden this can run and this can run at the same time. And if that happens, it's going to basically be going between launching voltage and intake voltage. It's going to be fighting each other. It's going to be trying to set it to one and then set it to the other, and weird things can start happening. So it's very important, because we're kind of taking this little bit of a shortcut, that you make sure that everything is an else if. So if, else if, else. Only one of those things can run at a time. And in our top section, our launching mode, it is again an if or an else. Only one of these two things can launch at a time. So we know that if this code is right, there will only be one set voltage. But that's something that I want to warn you about, because one of the hardest things to troubleshoot, like if it doesn't turn on, that's okay. You can figure out why it didn't turn on. That's kind of easy to troubleshoot. But when you set voltage in multiple places, it can do weird things. Like it could be going fast some of the time and slow some of the time. It could stop when it's not supposed to stop. It could do all kinds of weird things. It's much harder to track down that bug because it's just so weird in the ways that it can show itself. All right, let's try this. Let's deploy the code. Once again, I forgot to click deploy and then talk, so here we are again. All right, but when this runs, we're going to be checking for a couple things. So now we want to check that when we hold the launch button down, for 1 second, it's holding the balls in the hopper, the feed roller. And then after 1 second, it switches directions and starts sending the balls out. And we'll do that with no ball first, and then we'll add some balls to the robot and make sure that that is working. And then we also want to make sure that when we let go, things still turn off, right? I guess we check all the functions again just to make sure we didn't break anything with what we added. All right, teleoperated, enable. And so the first thing is, let me get the correct gamepad here. All right, so if I hold down the right bumper, that should put us in spin-up mode, and then 1 second later, launching mode. Let's give it a try. All right. So again, it's a little hard to see, but we're looking at this back roller here, especially these flaps on it. That's kind of what we want to see. So watch these flaps as they change directions after 1 second. So here we go. Kind of hard to see the change directions, but you did see a change in speed there. So that does look like it's working. Let's go ahead now and toss a ball in and see how that looks when we run it. All right, so again, I'm going to go straight into launching mode. So for 1 second, this ball should not be able to pass through here. It should be getting pushed away from that feed roller, and then it should launch the ball. That was pretty good. Let's try it one more time. And that did go to, I think that went over my head, right? So I'm about 6 feet tall, so if it's going over my head, it is going high enough to get it in the goal. I guess if I stand closer, we can know for sure. Yes. And that was my way of testing, was the spin-up time adequate, right? Was there enough spin-up time for the ball, or for the wheel to get up to full speed before it launched? And it is going, if it goes over my head, it's going over the 72 inches needed to go into the hopper. All right, we did say we need to test all of the other functions. So right now, we're in good shape in terms of off, because it's not doing anything. Let's, we can put a ball down and go ahead and try intaking it while driving. I guess I have to hold 2 controllers at the same time, but that should be fine. OK, intaking works. And then I'm going to, let's aim towards me. I'll play catch with the robot. Now we're going to do the eject button. Ooh, OK. Let's try that again. It is, let me see if we add a couple more in here, how that eject button works. OK, it looks better with multiple balls, but I don't know if you noticed, it kind of got stuck for a second before it ejected it out. We might be able to tune that. I don't want to prioritize the ejecting over launching, but there are a few things we can do. We can tune the values of the motors. We can go into our parameters and say, hey, when we're ejecting, actually, this motor needs to go a little faster, a little slower. We can try to tune those in to make it work better. And then the other thing that might have an effect is that pool noodle. We had that dead zone noodle in the middle there to make sure that we always had compression. If that's a little bit too big, that could have an effect. If it's a little bit too small, that could have an effect. So we could look at that a little bit later. The next thing I want to do, though, is we want to see kind of what happens if you're floor loading more than 1 ball at a time. We'll kind of give it a quick test for that. And then I think we want to dump a bunch in the hopper and try launching again. Although we did get a pretty good example of launching in our autonomous video. So let me get a few of these balls. We're going to try to pick up a few quickly together and see if anything weird happens, if we're launching any of them instead of intaking them. And can even try what happens if we pick up 2 at the same time. Maybe we'll try a couple of those. All right, so now let's see if we can get the robot lined up here. Oh yeah, I think we definitely need the ability to turn less. That is so hard. All right, and 2 balls is pretty close to the opening size. So that looks pretty close. All right, so now we're gonna go into loading mode and then start driving forward. That was good, man. It is possible that if I'm driving faster, which is I don't want to do here, we'll test that when we get out to the actual field, because I'm going to crash into stuff if I try to go fast. But it is possible that if we're driving faster, some of those balls might not work as well. But man, at that speed, that was no problem. I guess let's go ahead and just do a quick rotate over here, and let's launch them out and see if that's working as we hope. See, what had happened was I pressed the launch button, saw that they weren't feeding through, forgot that we had a spin up time and let go of the button. So it should be fine. Let's try again. And 1 second to spin up, and now there we go. All right. That is working, I would say, correctly. No problems. All the balls launched out. We had a little bit of a jam there. One of the things to keep in mind, of course, I'm holding one controller, not both controllers, but your driver may want to shake the robot a little bit if you have that jam. You could just give it a little back and forth to kind of shake the balls free, and that might help. That's something that we're going to practice or we're going to experiment more with out on the actual field. All right, let's disable this robot. I think the big thing that's missing is our ability to slow down a little bit in terms of turning and driving so that we have a little bit more precision when we're trying to line up on the balls and a little bit more precision when we're trying to line up on the goal to make sure it's there. Now, this is probably less important the better your driver gets. So, if your driver has a lot of practice and gets a good feel for the robot, then, they're going to want to go into slow mode less often because they can handle the higher speed. But certainly as you start practicing or if you don't get a lot of time to practice, this could be very helpful. So let's go ahead and set this up. Let's go all the way up to the very top. And we need to basically have what we want our reduced speed to be. So we have our fuel mechanism parameters. I'm going to go underneath that, and this is going to be our drive speed. I don't know. Let's call it parameters again, I guess. Cool. And we have the option of setting them together, but I think it's nice to have the option to set the turning speed and the driving speed a little bit differently. Now, you can't do this if you chose tank steering. You just have one variable. But if you went with arcade steering, you can make it so that your forward and backwards speed is adjusted differently than your left and right speed. OK, so let's make us a couple of variables here. If you're using not arcade mode, you're going to add one of these. Otherwise, you can add both. So we're going to do a private double. This could probably be a static final. Whatever. Let's just leave it as a private double. All right, and this is going to be, if you're doing tank drive, this is going to be our drive scaler, drive scale. Let's do, yeah. And then you could start at 1 speed, or you could choose what you want the slowed down speed to be. It could be like 0.5. So what we're putting in here is the default starting speed. We're going to switch between two different numbers. Now, if you're doing arcade drive, you need to do 2 of these. So we're going to have our, I guess we'll have drive speed, and that will work for both. And this is going to be our forward and backward speed. And let's go ahead and start out at full power, full speed. OK, and then we need another one. And this is going to be rotate speed. And we'll start out at full speed again. So again, if you are doing tank drive, you just need this one. You're going to use it everywhere. But if you're using arcade, we can use both of them. All right, now let's get all the way back down to Teleop again. And find your drive section here. And we need to get above the lines of code that we have for my drive. That has to be set after we've done any scaling that we want to do. OK, and essentially what we're going to do is we're going to say, hey, if we want to scale this down, if this is too fast, if I multiply here by 0.5, then that's like saying, hey, take whatever value we're getting from the controller, divide it in half, right? Multiplying by 0.5 is the same as dividing it in half, and then send that value. That basically says our maximum speed is now half speed, and any value I put in on the controller is divided by 2. So that gives me sort of twice as much control and half the total top speed. That's what we're going to do, but instead of doing a static number there, we're going to use a variable so that we can sometimes go full speed and sometimes go slower to have more control. All right, so let's go above here, and let's do an if. And this is now on the driver gamepad. They're going to have 2 buttons. For me, on the driver gamepad especially, because you have to have your thumbs on the joysticks, I don't want to have to move my thumb off of one of the joysticks to press like the B button or the A button and then like go back. That seems like a bad choice to me. So for the driver one especially, I really do like the bumpers, because then you can be driving and hitting those bumpers without ever losing control of the robot, of the movement of the robot. So I'm going to use left bumper to go slow mode and right bumper to go fast mode. All right. So in this case, we can do either one. Let's do slow mode first. So we're going to do drive controller. It's the name of our driver gamepad, dot get left bumper button. And we could use get left bumper button pressed or get left bumper button. I'm just going to use get left bumper button for now. All right, and then we open and close our parentheses. And all we want to do here is we're going to take our drive speed, and we're going to make that be equal to our slowed down value that you want to use. So like maybe slowed down is 70%. And then we have our rotate speed, and we're going to make that be equal to, I'm also going to do 70%, but remember, well, let's start at 80% and see how that feels. I think that's what, so there is some notes for the first code, which kind of gives you these speeds. And I think the idea is sometimes you want to be able to rotate, or rotating can slow down a lot quicker than driving forward and backwards, just because the motors are working against each other instead of working together. So maybe we want that number higher. I think I might test this and decide I want both of these numbers lower. But then I am like in a room where things are close by and I don't want to crash into them. So like naturally right now I feel like I want the thing to move slower. But when we go out to the field and put it down and there's lots of space and it's like okay to crash into some of the walls that are out there, then I probably want to turn it up a little bit. So we'll see. But that seems fine. That's slow mode. Then what we can do is we can say, hey, we could do an else if, or we could just do another if. Let's do an else if. Why not? Okay, else if driver controller dot get right bumper button. So now if we press the right button, what do we want to do? Well, we want drive speed to go all the way back up to 1, full power, and we want rotate speed to go all the way back up to 1 or full power. Now you might decide that never ever do you want to rotate at full speed, in which case, you could still make this be like 0.9. So it only slows down a little bit. You have that option. Just because it's our fast mode doesn't mean you have to go full speed. All right, and we can do our comments here. So this would be like set slower driving mode. And this would be set faster driving mode. In our case right now, it is full power. Okay, so now it's basically these variables. We have this drive speed and rotate speed. They have a number saved in them. So if you press this button, drive speed is equal to 0.7 and rotate speed is equal to 0.8. If you press this button, then they're both equal to 1. Well, so now in our actual output where we send the power to the motors, or we send it to the arcade drive, which will then figure out what power to send to the motors, we can just add that times our drive speed on this one. I think I want spaces so it's easier to see. And then on this one, we're going to do times our rotate speed. And that is it. That's going to make it work. Now, if you're doing the tank drive line above, I'm going to uncomment it real quick. Don't do that if you're doing arcade. But just if you are a tank drive person, it's going to be the same thing, times drive speed. And this one is also going to be times drive speed. Which means, of course, if you're doing tank drive, you do not need rotate speed here, and you do not need rotate speed here. Of course, if you did it, it's not going to hurt anything. Okay, I'm going to comment that back out. All right, so now we have our 2 different speeds. Now, I think 0.7 and 0.8 might be a good choice, but for my test here, I'm actually going to change these numbers. I just decided 0.8 might be too close to full speed. It might be hard to see the difference. I'm going to go 0.5 and 0.6. in here, because I really want you to see that, okay, it's going way slower when I'm in slow mode. All right, let's deploy this. And then we will give it a try. I'm gonna maybe get the fuel out of the way so I don't crash into it when we're doing our testing. All right, it is deployed. I'm going to now Teleop enable and get the driver gamepad here. All right, so it starts at full speed. I think the easiest way for me to show you what's happening is that's rotate speed right now. All right, now we hit the left bumper button. The left bumper button is the one that is going to turn it into slow mode, so I'll click that. Now it should be in slow mode. So now when we rotate, and that is full speed. I'm all the way over on the gamepad here. So it's very clear that there's a difference. So I can even start spinning, and while I'm spinning, I'm going to hit the full speed button. And now the half speed button. So that is the way we know it is for sure working. Same thing, if I drive forward, that's full power. That's full power forward and backwards. But of course, when I hit the full power button, it takes off. All right, so we know that's working. Now we can go back. Let's make one more change. Let's go up to the 0.7 and 0.8 and see how those numbers feel and if we like them or not. All right, so for drive speed slow, we'll do 0.7. For rotate, we'll go back to 0.8 and then deploy that code. And again, these numbers are not like locked in. These numbers are totally like when your driver is practicing, if it feels too fast for them and you have the slow mode and they like the slow mode, that's the right value. If slow mode feels too slow, speed it up. If slow mode feels too fast, slow it down even more. And like I said, there is potentially a world where the turning is just so quick when you get out to the extremes that you want to always have turning at 0.9 or something like that. That is totally fine as well. All right, we are up and running. Let's go enable on this. All right, and now let's see. So this is still full power. We start at full power. I'm going to hit slow mode, and I'm just going to drive around for a little bit and see how it feels. I think, okay, let's say really quickly, I want to turn and aim at the toolbox. That's not too bad. I could see maybe turning down the rotate speed a little bit. But, you know, test yours, figure out what you like, and just tweak these values until you're happy with it. Yeah, I could definitely see rotate might still be a little too fast for me. I actually think I personally might want to flip these to where driving stays fast, but rotating gets a little slower. But figure out what you want, drive it around a little bit, test it. But that's basically all the code we need for teleoperated mode. We have control of the drive. We can change the speed. We can, of course, move and turn. We have control of our fuel mechanism. We have our intake. We have the eject working and launch with the spin-up time working. And again, remember, if you're running into some of those problems, we might see some more of those problems when we go field side and we can do some tweaking. But if you run into some problems where like, oh, it's not, when you launch the ball, it's not getting 6 feet high, just go into that launching value for the launcher wheel. And I think it's set at 10.6 right now. Move it up to 11, see if that helps. You can go all the way up to 12, no problem. All right, next video, we're going to take this to the field. We're going to put it through its paces, see if we can get any bugs happening so we can try to fix those. And we will see you in that video. But before we go, another special thanks to Argosy, First, Aramco, and Team 302, Lake Orion High School for hosting our studio.